Hi friends, this video is about scientific notation. Remember, scientific notation is a way that we write very large or very small numbers. People in professions like science and engineering, mathematics, finance, oftentimes need ways to write very large and very small numbers accurately and easy. So scientific notation starts with a number that's either very large or very small. So I have two examples here that we're going to start with. One is a very large number and one is a very small number. In order to write it in scientific notation, you find the decimal point. The decimal point is right there for that guy. Now we're going to move the decimal point, and we're going to keep moving him until when we stop, we have a number that's between 1 and 10. So here we go. Move, move, move. Another move, another move. If I stop here, I'm at a number 52.2. That's too big. I have to move one more time. And my new decimal point now is at 522. And we don't have to write all those zeros. But we have to figure out how many times we moved. So we're going to count 1, 2, 3, 4, 5, 6. We made 6 moves, and we're going to use a positive exponent because my number started out very large. In number 2, my number is starting out very small, and we're going to use a negative exponent when we ultimately write it down. Again, we're going to start by finding the decimal point. There it is. And we're going to move it to the right until when we stop, not here because I'm at 0.64, right there, I'm at a number between 1 and 10, which is 6.4. Times, and the power of 10, we know it's going to be negative, and now I need to count my number of moves. 1, 2, 3, 4, 5. I moved 5 moves, and it's negative because the number started out very small. The other examples I wanted to run through with you are turning a number back in to standard notation when it's in scientific notation. Somehow these got kind of crowded together, so what I'm going to do is I'm going to work this problem right here. 9.45 times 10 to the negative 5. In order to turn them into standard form, I find the decimal point in 9.45. There he is. I'll erase this arrow because I'm going to move the decimal point. Now I'm going to move it to the left to make him smaller because of this negative exponent. I need to move it 5 places. There's one of my moves. Now I need 4 more moves, and I don't have any more numbers. So I can just add 4 zeros and put my decimal point. So my number in standard notation is this. No, scientific notation, sorry. My number in standard notation is this. This is standard. This is scientific. There's one more that I have written here, this 6.32 times 10 to the 6th. Again, we start with the decimal point. My power is positive, so I'm going to make this 6.32 bigger by moving my decimal point 6 places to the right. There's 2 moves right there. I need 4 more moves. You can simply add 4 more zeros. So I have 6, 3, 2, 0, 0, 0, 0. Now you need to put your commas in and make this a real number. There's a comma, there's a comma. So 6,320,000 is the standard notation for the scientific notation that we started with. Okay, one last little thing. We use scientific notation to compare numbers. And in order to compare numbers, all of your numbers need to be in scientific notation. That guy's not. So let's do that first. 481,000, find the decimal point right here. Move along to the left until you can stop at a number between 1 and 10. Can't stop here. I'm at 48.1. There we go. 4.81 times 10. You know your exponent's going to be positive because your number started out big. And we moved how many? 1, 2, 3, 4, 5. 10 to the 5. Now, let's bring these other guys down. This one's kind of an example that doesn't have any different exponents, and I wish I had put some different exponents on here for you. The first thing you are going to look at is the exponents. The smallest exponent will be the smallest number. The largest exponent will be the largest number. But what do you do when you have a case where all the exponents are the same, or some of them are the same? Then you have to look at the number in front. The smallest number in front is this guy. He will be the smallest number. The second smallest number, by just a hair of his chinny chin chin, is this guy. And this guy is our largest. So be sure to look at your exponents first, and your biggest exponent will be your biggest number, and you don't even have to look at the numbers in front. Thanks for watching. Bye-bye.